Hello everyone. So we are gonna do Leetcode 2037, minimum number of moves to seat everyone. In this question, you're given n seats and n students in a room, and you're given an array seats of length n, where seats of I is the position of the ith seat. Similarly, you're given a student array where student of I is the position of the ith student, or student of j is the position of the jth student. We can perform the following operation. We can increase or decrease the position of the ith student by 1. It means we can move the student left by 1, or we can move the student right by 1, or we can let the student be at its place. Okay, you can change his position from x to x plus 1, or let it be x, or to x minus 1. So we have to return the minimum number of moves required to move each student to a seat such that no students are in the same seat. So we don't have to make the student sit on the same seat. Now when I say same seat, it doesn't mean the position of the seat cannot be same. Yeah, we will discuss that later. So see this important line: there may be multiple seats or students in the same position at the beginning. Okay, so let's understand the question with this example. These are the position of the seats that are given to you, and these are the positions of the students that are given to you. So it on a number line, you can represent these as like this. Okay, so seats are at 2 2 6 6. So I have drawn the seats at 2 2. There are two seats at the position 2, and there are two seats at the position 6. So it's 2 2 6 6, and the positions of the student is 1 3 2 6. 1 is here, 3 2 6. So these are the position of these students. Now you have to make these students sit on the seats. So in which way does it seem more logical to make them sit so that it takes the minimum number of moves? The student 2 is already here. Why don't we just make him sit here at the position 2 only? So no operations required, right? No operations required. This student is done. Now let's talk about the student 1. Okay, student 1, well, I can make him sit here, but does it make sense to make him sit at such a large distance? No. We will choose the closest seat to student 1, right? So this is the closest seat. Now coming to student 3, these two seats are occupied. Obviously we would have chosen this for student 3, but these two have already been chosen. So we will choose this seat for student 3, and for student 6, obviously no need to move him, so he is there only. So what is the minimum number of operations required? Let's calculate now. Let's begin with the student 1. So he has to move, so we need one operation here. Okay, we need 0 operations here, and for this guy we need 1 2 3 operations, right? So we need 3 operations here, and for student 6 we need 0 operations. So how many operations do we need in total? 1 plus 3 is 4. So there we need 4 operations in total. So the output for this is 4. Yeah, now let's discuss the second example for more clear understanding. Again, seats are given, students are given, and I have visualized this on a number line. These are the seats, the green boxes are the seats, and these are the students. Okay, now let's start to make them sit. Obviously student and seats are the same position. I don't think we need to make a move. Yeah, let them be there. So it's a kind of a greedy approach. Now student 2 is here. The nearest seat to student 2 is this seat. Yeah, so let's make the student 2 sit over here. Now the nearest seat for student 3 is going to be this seat, so let's make the student 3 sit there. And for student 6, obviously this seat is remaining, so let him sit here. Logically there is no other way to make them sit together, so that number of moves is minimum. So focus on that. We have to minimize the number of moves. That's why we are choosing the closest seat to each of the student. We are choosing the closest seat to each of the student. Now how will we implement that in coding? Because this is common sense, right? So the first thing that we should be doing is we need to sort these two arrays, because the order of the array doesn't matter. Sorting these arrays will help us know the closest seat that is available for a student, or we can calculate the distance of the seat from the student. First of all, let's calculate the answer to this question. So student 1 need not to move at all, so it's 0, right? A student 2 needed to move 1 2 steps, so it's plus 2. For student 3, it's going to be 1 2, again 2 steps for student 3, so it's going to be plus 2. For student 6, it's going to be 1 2 3. he has to move 3 moves in total. So what is the total answer? 2 plus 2 plus 3, 0 doesn't matter, so it's gonna be 7. 7 should be the answer. I said we need to sort these arrays, so let's sort those arrays. After sorting, the seeds array will become this: 1 4 5 9. Students array will become 1 2 3 6. Now obviously the size of both the arrays is gonna be same, because the number of students is equal to the number of seats is equals to n. So student 1 needs to be moved to the first element of the seats. Now obviously the moves required is 1 minus 1 0. No moves required. Here student at position 2 needs to be moved to the seat at position 4. So how many moves are required? Okay, we will need 2 minus 4 movement, right? We can take the mod of it, because it doesn't matter whether we'll move left or right. We are considering that move as positive move. Okay, moving to the left by 1 or to the right by 1 is considered one move, so it's gonna be 2. Now coming over to the third element, 3 minus 5 or 5 minus 3, whatever way you like, we will take a mod of it, so it becomes again 2. And then 9 minus 6 or 6 minus 9, so we will get 3. So 3 plus 2 plus 2, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 0 is 7. So this way the answer is coming out to be 7. Now let's talk about the coding implementation of the above problem. So first of all, we're going to sort the seat array and the student array. So we're going to sort the seats and we're going to sort the students array. So I'm going to write a pseudo code first of all. We know the length of the array is n. Let this length of the array be n. Then we declare an answer variable. Let's make it start with 0, and then we will start looping from the first element till the last element of the array, and for each of the element we will take the absolute value of the difference between the position of the seat and the position of the student. That's what we are going to do, and we're going to add it up to the answer, and finally we are going to return the answer. This answer will represent total number of minimum moves required to make all the students seated. Minimum moves required to make all the students seated. So let's see C++ code of. So we were going to do exactly what we discussed. So our first step was sorting out both the arrays. So let's sort the seats and the students array. After sorting them, let's declare the variable in which we are going to store the answer. Let this be answer. Okay, and let's initialize it with 0. And now we're going to loop till the size of the array. So we can take any one of the sizes, because the size of both the arrays is the same. And after that we are going to add the absolute difference between the position of the seats and the students. After doing it for every element, we're going to return the answer. Now let's submit it. So I think that helps. Thank you.